This video goes through calculating the projection of vectors or the projection resolute. Now, a good way to think about the projection of A on B is as the vector that is a shadow that A produces on B. So just to try and think about this, if this is vector B and this is vector A, then A projected on B is its shadow. So the shadow of A on B, and this will be a right angle there. So any vector in three dimensions can be expressed in the form of r equals xi plus yj plus zk, which we've already gone through. So that means xi is the vector projection of r on x. Yi is the vector projection of r on y, and zi is the vector projection of r on z. So let's look at an example. We have a vector OF, this orange vector here, projected onto our x-axis. So there's our right angle. It would be this vector here, which is equal to -6i. That vector OF projected onto our y-axis, so there's our right angle. This is -3, and the vector is -3j. So similarly projected onto our z-axis. So this is our z-axis representation here. This would be our 0 point. So that vector there would be 3k. And you can see the same thing with our vector O down the bottom. So follow it through and see those projections. Now, x, y, z are the scalar projections, so magnitude only, not direction, of r parallel to the x, y, and z axes respectively. The dot products r I, Rj, and Rk give the scalar projections of R in the x, y, and z directions respectively. So first of all, let's look at these two diagrams. And these diagrams, C is the vector projection of vector A in the direction of B. So here's my vector C here, and in my other diagram, there's my vector C there. So one where theta is acute and the other where theta is obtuse. So our scalar projection, the magnitude of C, our vector C, also called the modulus of C, is called the scalar projection of vector A on vector B. So the scalar projection of A on B, or the magnitude of C is the other way to think about it, is the dot product between A and the unit vector B, which can be written as the dot product of A and B over the magnitude of B. The scalar projection of B on A is the dot product of B and the unit vector A, which can be written as the dot product of B and A, which is the same as the dot product between A and B, over the magnitude of A. If we're looking at the vector projection of A onto B, so now we have direction, our C will equal the magnitude of C times by the unit vector B, which can be rewritten as the dot product between A and the unit vector B times by the unit vector of B. So you can see the thing that I've added between the scalar projection and the vector projection is multiplying by the unit vector of B. So the vector projection or component of A on B is the dot product of A and the unit vector B times by the unit vector of B. Now combining these two formulas, so as you can see with the arrow, I can rewrite this formula as the dot product between A and B over the magnitude of B times by the unit vector of B. Now have a look at your formula sheet. Look at the formula that's given on your formula sheet. Moving on, that's how we find the vector projection of A on B. We can also look at the vector projection of a perpendicular to B. So that's this vector here. Okay, now that's also called the vector rejection of A on B. The key for finding that is it's minus the vector projection plus A, or other way of looking at it, A minus the vector projection. So that is your formula there. Now, just to clarify with our formula, if we look at the scalar projection of A on B, that you have A dot the unit vector of B, remember that the unit vector of B is equal to B over the magnitude of B. So that's where the next formula comes from. Similarly, for B dot the unit vector of A, the unit vector of A is equal to A over the magnitude of A. So you can see that I've just replaced that unit vector of A with A over the magnitude of A. So that should make it easier for you to remember the formulas. Okay, so looking at this next formula here for the vector projection of or component of A on B. So you have A and B, the unit vector of B as a dot product, times by the unit vector of B. All we're doing is replacing this unit vector of B with B on the magnitude of B. So you don't have to remember lots of formulas. You just have to remember that the unit vector of A is A over the magnitude of A, or the unit vector of B is B over the magnitude of B. So digest this video before watching the videos that go through some examples.